Determine for the function g of x equals 1 minus x squared for x is less than or equal to 3, 5 minus 3x for x is greater than 3 and less than 4, negative 6 for x equals 4, and x squared minus 6x plus 3 for x is greater than 4. At each of the x coordinates x equals 3 and x equals 4, whether it is parts a through e. Each of the parts involves the continuity of the function, so the first thing to do is write down the definition of what it means to be continuous. And that's going to be the limit as x approaches a from both sides of g of x equals g of a. We're looking at specifically the x coordinates of 3 and 4 here, so we can write this definition down for each of those. Limit as x approaches 3 from both sides of g of x equals g of 3, and limit as x approaches 4 from both sides of g of x equals g of 4. Now we don't know whether either of these are true yet or not, so we'll put question marks above them, but if they are true, those are the conditions needed for it to be continuous at each of those x coordinates. The first thing to work out here is the limit as x approaches 3 from both sides of g of x. G of x is a split expression function, and it's splitting right at the x coordinate of 3. So the limit from both sides of 3 will have to be worked out from each side separately. So we'll have the limit as x approaches 3 from the left side of g of x, as well as the limit as x approaches 3 from the right side of g of x. Let's start with the left side limit. The left side of 3 means less than 3, so the expression we'll use for g of x will be this one. So we can now replace g of x with a 1 minus x squared. We can now try plugging a 3 in for each of the x's. That'll give us 1 minus 3 squared. 3 squared is a 9, so we have 1 minus 9, which is a negative 8. And we can now work out the right side limit of 3. That means greater than 3. And that means we'll use this from the split expression function for our expression. So we can replace g of x with 5 minus 3x. And we can now try plugging a 3 in for each of the x's. That'll give us 5 minus 3 times 3, which is 5 minus 9, which is a negative 4. The two-sided limit depends on the results of the two one-sided limits. Here they are. They do not match each other, so the two-sided limit will be does not exist. Last thing to work out is g of 3, and that means g evaluated right at an x-coordinate of 3, so we look at where x can equal 3 from the split expression function. 3 is included there, so we plug that 3 in for the 1 minus x squared expression, so it'll be 1 minus 3 squared, which is 1 minus a 9, which is a negative 8. So to recap the results of the x-coordinate of 3, we have the limit as x approaches 3 from the right side of g of x does not equal the limit as x approaches 3 from the left side of g of x, which means we will have a jump discontinuity. And it turns out that g of 3 does match the left side limit but not the right side limit, so it will equal the left side limit, and therefore we still have it being continuous from the left side even though it is a jump discontinuity. That's situation C. So we will go with jump discontinuous but continuous from the left side for the x-coordinate of 3. Now we can look at the x-coordinate of 4. We will start with the two-sided limit as x approaches 4 from both sides of g of x. Since the split expression function splits right at the x-coordinate of 4, we will have to work out the two-sided limit as two one-sided limits separately. So we'll have the limit as x approaches 4 from the left side of g of x, and limit as x approaches 4 from the right side of g of x. Let's start with the left side limit. The left side of 4 means less than 4. It does have to stay near to 4 though, so we will want to choose this. So we will have 5 minus 3x able to replace the g of x. We can now try plugging in x value of 4 in. That'll give us 5 minus 3 times 4. Negative 3 times 4 is negative 12. 5 minus 12 is a negative 7. We can now work out the right side limit. The right side of 4 is greater than 4 from the split expression function. That will give us that expression. So we have the limit as x approaches 4 from the right side of x squared minus 6x plus 3 can replace the g of x. We can now try plugging in an x value of 4 for each of the x's. So we'll have 4 squared minus 6 times 4 plus 3. 4 squared is 16, minus 6 times 4 is negative 24, and then plus 3. 16 minus 24 is negative 8, plus 3 is negative 5. The two-sided limit depends on the results of the two one-sided limits. There they are. They do not match each other, so the two-sided limit will be does not exist. And once again, we do have a jump discontinuity, for which type depends on what the g is at the x-coordinate of 4. So we will now determine g of 4. To determine that, we look at where x can include 4, and that's here, and according to that, g of 4 is a negative 6. So to recap the results for the x-coordinate of 4, we have the limit as x approaches 4 from the left side of g of x does not equal the limit as x approaches 4 from the right side of g of x, and this does not equal g of 4 either. Since the left and right side limits do not match each other, we have a jump discontinuity, but because g of 4 doesn't equal either the left or the right limits, we have that it's continuous from neither side. We will have situation E, and we have that it is jump discontinuous and continuous from neither side at the x-coordinate of 4.